first image under the J function are algebraic. Okay? And additionally, thank you. Totally falling here. Sorry.
Just a technical problem.
Oh, we'll see, I guess. Is it possible to sort of... This was predictable, right? Yeah. Okay, anyways, I'll keep talking. So, so if and only if tau and J of tau are both algebraic, and equivalently, tau is a quadratic imaginary. Okay, a few more facts just for analogy. So, secondly, the collection of CMJ invariants over a given number field. So, over a fixed number field K is finite. But I want to point out that this is not a Northcott property. So, in other words, the collection of complex multiplication J invariants is not a set of bounded height, where recall here, by height I mean just the measure of the arithmetic complexity. How long does it take you to write down the minimal polynomial of the number? So they're not a set of bounded height, but nonetheless they satisfy this finiteness property. Okay. So I claimed that I was interested in the geometry of these things, but that in the one parameter setting this isn't so interesting to ask. So let's instead consider a two-parameter space. The easiest one we can build up in this situation is to consider instead C cross C to parameterize pairs of elliptic curves. Okay. In this setting again, sorry, this is a 0. In this setting again, this collection will be Zariski dense in the parameter space, so CM, J invariants are Zariski dense in the parameter space. What do I mean by a CMJ invariant in this case?
Learning how to compute these things in various mathematical or analytic ways. The primary difference of what I'm going to talk about today is how to compute them, doing it computationally rather than mathematically, and also a little bit about how to interpret what they mean. Probably the most important idea that I want to convey is that this is the right order of importance. If you measure something, the primary thing that I care about is the measurement that you made, the size of the effect. If that's all you tell me, that would probably be okay most of the time. Just tell me how big it is. My second question is going to be how accurate is your measurement? Again, we're going to quantify the precision of the measurement, but I'm going to claim that this is a somewhat less important thing. And now a distant third important thing is to tell me whether the thing that you measured might actually be 0. And I'd like to have some notion of whether that might be true by chance or not. The problem that I see is that a lot of papers flip this around. So instead of effect size, most important thing, and p-value, distant third, what I often see is papers that have p-values in the abstract, as if it was the most important.
ちょっと雨降り出したんで今日はやめます。